Okay, so I'd say for all these problems, I know some of you have like seen these before, so some of them might be like, all right, you just know how to do this off the bat. But when you're tackling these problems, like what I recommend doing are like these steps. And I know I've said these before, but it's a good review. So one, give yourself an example. Like this, like we have an example here. And two, just answer the question. So if we say, what is the minimum in this list? The answer is maybe 39, 79. It looks like 39. Okay, so the answer is, for example, 39. Step 3 is, it is your job now, this is like the hardest part, figure out what your brain did to answer the question. Okay? 4, write down the steps that your brain took. 5, translate the steps into code. Give me 1 second. Oh, Serge answered the question for me. 36, that's right. All right, so, 36. I was wrong, thank you. Okay. So now we give ourselves an example, we answer the question. How did, my brain do it incorrectly? All right, well, what I tried to do was keep 64. Okay, I guess 39, I was like, okay, 64, and then I just held on to the number 39. And then I kept going, 39, 39, 39. Okay, and then finally we'll get to 36. So what I'm doing, I think, is I'm keeping track of what we'll call a current min. Okay? And then go through each number, updating the current min if we find a number smaller, right? And then when we get to the end, I would say if we find a number smaller, that's our new current min. Okay? When we get to the end, current min is the global min, right? Is our minimum number all overall. Now, the reason why, I think for some of you this was pretty straightforward is because, if you've seen this concept before of a current minimum or current maximum, right? And then you get to the end of the list and then you have a global, right? The point is these are good concepts to hold on to, is this idea of okay, we can kind of set the first number 64, whatever the first number is, as our current minimum, then go to the next number. If this number is lower than our current minimum, this is our new current minimum. Then go to the next number, right? And the cost of this should just be n, I believe, right? Because you're just looping through it one time. So let's try this. So for a number, let's call these elements, right? Let's say for element in elements, what do I want to do? So first thing I should do is say the current min equals elements of 0. So you can do this. You can just say the first element is that. Well, we'll just do that for now, and then I'll show you another technique. For element in elements, set the current minimum equal to the first element, right? And then we can say if element is less than the current element, right? Then current element equals the element. Current minimum. If element is less than the current minimum, then the current min equals, we're going to assign the current minimum now to be this element that we're on, right? And then finally, when we're done, we can return the current min, and that is our global min. right? So I will see. I don't know. So let's just take a look. Let's just try it, and then we can go through it again. Oh, good. Yeah, that looks right. Okay, so we set this number. This is start off as 64. And then we say for each element in the list of elements, so starting with 64. So if 64 is less than 64, it doesn't matter. The current minimum, it will be equal to 64. It's not less than, so we won't even get here. But then we move to the next number. If the element 39 is less than 64, right? Then current min equals 39. So we can just print out, we'll just see what happens here. Print the current min. So you can kind of see what happens. As we go through, we get our first number that's less than the current min, that's 39. Then we keep going until we get to 36. Now we finally also pass this if block because 36 is less than 39. And then we do current min now equals 36 and then print that out. Okay. So again, it's kind of like a couple concepts. Biggest concept is try to follow this technique. Second, kind of like meaning, have an example, answer the question. Now you have to go through what did your brain do, right, to actually do that. Translate this write the steps. Translate the steps into code. It's very good. It's like when I studied for the LSAT, it was like certain problems at the beginning are generally pretty easy, but you have this you have your test prep book that tells you the procedure. You want to follow the procedure even when the problem's easy, at least when you're practicing, because when it comes time for the test, you're not at 100%. You're 90% if you're lucky. So you want to be able to lean on these steps. All right, that's my point. And especially if the problem becomes hard, you want to again just have this as a habit that you can always lean on. All right. So I really recommend when you're going through these problems, you may be able to be like, I got this, and you do, but still try to enforce this technique because it's a good thing to have in your back pocket. All right. Questions about... Oh, so that was kind of step one, is this technique. And then the second thing is this idea of the current minimum, right? And then when you get to the end, we have a global minimum, right? So we'll just kind of say, okay, for now, 64 is our minimum. And then we keep going, okay, for now, 39 is our minimum, right? The number when we get to the end of the list that's been smaller than all the other numbers, right? That's our new current minimum, is our global minimum. So that's obviously it works for maximum too. And this concept comes up. All right. The other way that you can do something like this is, I'll have to Google it, Python negative infinity, is you can just set it equal to a number. Oh, it would be positive infinity, I guess. Float, we can set this equal to float infinity. So if you're we're here. It basically has the same effect. If you want to say, all right, there's no way this is going to be our minimum, right? It's going to be one. So this is our current minimum, which is the biggest number possible. And now go through all the rest of the numbers, right? And now this is going to be our current minimum. So we can just see how this works. I believe this will. The only difference will be now it prints out 64, right? Because the first number is obviously less than infinity. So if the element is less than current min, 64 is now our current minimum. It doesn't make much difference. It doesn't make any difference practically. Okay, questions about this problem? All right, and then here, let's follow the same tech. Yeah, go ahead, Serge.
How many returns? Do you have 3, 4 returns?
No, I just have
If
one.
you use the float infin? Oh, that's because you had the print statement.
Yeah.
Oh, okay.
So it's just at the end, when you go through all the numbers, that's when I know that the current minimum is my overall. So I have to go through. If I had to return too early, right, it wouldn't work. I have to make sure it's after the loop.
Thanks.
Cool. Other questions about this? All right, finding uniqueness. Okay, again, we have an example. We're told these numbers are not unique. So first, answer the question. How would you figure out if these are not unique? Or like maybe even better, think of like a deck of cards, you know, like, and you maybe have two decks, you know, they're like one of these decks you find at like your parents' house and you're like not sure if it's a valid deck of cards, maybe it has some extra cards in it. How are you gonna know if there's some extra cards in it, right? You probably organize them, right? You probably put them in order. So what I would do, like this problem is gonna be easier for me to answer. And we can show it a harder way too. But if we're just following our steps of answer the question, or give yourself an example, just answer the question, and then figure out what your brain did. I can't even answer this question, but I could if I probably like sorted this list. And now, you know, maybe I look at, okay, here's my problem. Okay? So this made it my problem a lot easier immediately. Right? Oh, here's another problem. Okay? So now, what do? If the number, if the value is the same as the next value, then I have a problem. And that's it, I think. Right? Because that's the only way. Like, if the values are not, if we have duplicates, they're going to be right next to each other once we sort the list. 4 element. Now this is going to be hard. Okay, this kind of introduces a nice thing. It's like, how do I access the next number? All right? So there's a couple ways. I say, one is maybe instead of looping through the elements themselves, we loop through like a counter, like the length of the list. All right? So we can say, you know, for index in range up to the length of the unique elements or non-unique elements. All right, and let's just like print the index, I guess, for now. All right, so you can see we go up to 1 minus, I think, the length of the list. So it's 44. So we go to 0 to 44, right? And the length of the list, I believe, must be 45. Right? So we go through, this is one way to access every element in the list, right? We can just say non-unique elements, bracket index, right? And we didn't print them, but this would print every element. Okay, so this is a way to access every element in the list. Well, then what we can do is we can compare the element to the next one, right? And this will work except for when we get to the end, we're going to be looking for the next element, and it's going to say listed, you know, we're out of range because there is no next element. But we can look at it, we can try it. Okay, does the current element, I'll just call this current element, and then the next element, that is the index plus 1, right? That's the next element. Then we can say if the current element equals the next element, so we loop through. If the current element, I must be spelling this wrong, equals the next element colon, then return false, right? Okay, and we'll just call this elements. We'll call this elements. All right, so we pass through a list of elements, this function. We go through all the indices to basically select the current element and the next one. If the current element equals the next one, then we return false. Otherwise, if we get to the end and there's nothing, then we return true, right? And there is no kind of equal, the current equals the next one, then we can return true. All right. Again, we're going to have this problem where once we get to this number 46, we're going to look for negative 46 plus 1, and then, we got a problem. It's going to give us an error, but let's just see the error first. Is unique of non-unique element. Oh, we should probably do the unique elements because we want to get to that end. All right. There. Oh shoot, that wasn't what I expected. Unique elements. Let's define it. Now let's run it. There you go. List index out of range. Exactly what we thought, right? Elements got to the one that's too big, and now we're looking for this thing plus 1. It's not there. So what can we do? We probably just take this number and minus 1, I'm guessing, right? Just do 1 less, and now we'll probably be fine. Shoot, I can't do that. So this is a range, length of elements minus 1, right? So if this is length of the elements is like 45, we'll just do minus 1 of that. So and now we got to the unique, that looks good. And let's do the non-unique. So is it unique? The answer is true. How about non-unique? That was not what I expected. Okay. Non-unique elements. So we have a problem. Well, we're not sorting it, guys. Come on. Right? We want to loop through our sorted elements. So we can call this sorted elements, and let's just go through that, right? So it's the sorted elements current is the sorted elements next, and I guess for good measure, this doesn't matter. So let's just see this, and then happy to go through some questions. So now non-unique elements is false, and let's do this. The next one is unique for unique elements. And that is true. All right, yeah, Sonia.
I'm sorry, I actually was trying to do this big OLAB with brute force, and so I was going to say, hey, aren't we supposed to not be using sorted? But
sure, we can.
That was my mistake.
No, that's cool. We can go through. I do want to go through the brute force as well, so we can do that. All right. Okay, so this seems to have worked, right? If all the elements, yeah. All right, not bad. Let's try to, this is a good point. Let's try to do it with brute force, meaning the other way to do this. So what's the brute force way? Try everything, right? Brute force just means, all right, let's try everything. So what does that mean? We're going to have to take our current number and compare it against every other number. Okay? This brings up, so let's just write this out. Take the current number, compare against every other number. I mean, we could say compare against every other number, or probably I think what's better is like compare against every succeeding number. So you can start at 78 and then compare it against all of these, and then you can go to 81. We know 81 doesn't equal the preceding one, otherwise we would have told us we'd be over. And you compare 81 against every other one. So how do we do that, right? So I think the first step is for every number, we want the current, and then we want to get the current, and then we want everything after, right? A list of everything after. So let's see if we can just do that. So for num, for each element in elements, and now this is going to be tricky. So one thing we could do is, again, we need the index, right? We need the index of the current number. So how should we do this? One way, I guess, is to do this range thing, right? Where we loop through, we could show a couple ways. So for index in range length of the elements, right? Just, print I index. And now, right, it just prints our numbers. And now it's a matter of, okay, it's the same kind of thing. Here's my current element equals the elements bracket index, right? That's the current element. And then what's every other element? So if the current element is 0, we need to select 1 on, right? So that would be all others equals, or all succeeding, we should say, successive elements equals the current index plus 1. We need to slice this, right? Plus 1 on. And let's just print both of these. Print current element, comma, the successive elements. Oh, that's fun. Okay, so 78, and then all the rest of them, right? 81, and then all the rest of them. So right, we're starting at 63. So negative 78, then all the rest of them is this. Okay. So and now what do we need to do? So for the current, take the current number, compare against every other number. So now we'd have to say, for num in for a successive element in all successive elements, if the current num equals the successive element, then we're done, right? Then it's a current element, I should just call it. Then a return false, right? We found a match. If we get to the end of every loop, basically get to the end of the nested loop, then we can return true. Okay? So we compare 78, we go through all the rest of them, then that 78 is good. Then we go to 81, compare against all the rest of them, 81 is good. Then we do 63, right? We get to the very end, then we're good. So this is so now we'll try it. So first we have our non-unique elements, so this should return false. So it should find in one of these successive elements a match with the current one. That returns false. And now let's try the unique elements. That returns true. Alright? So this is one way to do it, is like when we care about the index, use the range. Use this index range thing. Another way you can do this is basically we want this number to start at 1, right? 0 plus 1, and then go to 2, and then go to 3, right? So another way you can do this is you can just set a counter here equal to 0, and then every time we loop through, we'll just do for element in elements. We'll call this for current elements still, I guess. So for each number, like 78, then check it, take 78, negative 78, check it against all the rest of them. So take negative 78 and then find all successive elements. The other way to do all successive elements is say we're basically going to increment our counter by 1 each time. So you can do counter equals counter plus 1, right? Counter equals 0 plus 1. And every time we go through the loop, we'll increment it. And then we want to select, well, I guess so it would be here, would just be 1 on. Then we go to the next element, 81, and then we want to select 2 on, 0, 1, 2 on, right? And so on. So this will be our way of finding the successive elements. Right, so this is another way you can do this, is with a counter. Okay, let's see if we still get it. This should be non-unique elements. All right. So that's the second way. is with the counter, right? And counters are like very useful to kind of know about. And the third thing to know about is when you loop through, right? Because in each case, what are we trying to do? We're basically trying to find a way to track, like the current index, like what is the what number are we on, right? So that we use the range as a way to do it. We use this counter thing as a way to do it. Another way you can do this, I'll just show this maybe separately. Say we have these like 5 numbers. We can use this function called enumerate nums. So you go through each number, but now you're going to do enumerate, and this will give you, I think it's number comma index. Let's just print this out. I always forget the order. I reversed it. It's index comma number. All right, so you can see what this does. We start with this list, and now we want to associate an index with each element in the list. So to do that, this is the current index, right? And we can use that down here, right? It's the same kind of thing. We can just, I'll just copy this so we can keep it. So this time we'll say for current element, for index, comma, current element in enumerate elements, all successive elements, the first element, this is going to be 0, is going to be index plus 1. And then we can go through for successive elements and elements. If the current element, this number -78, equals any of the successive elements, return false, otherwise return true. Otherwise, if we get to the very, very end, then return true. Oh, but that's not what I wanted. So now we want to do is unique of unique elements and is unique of non-unique elements. So unique elements, we got it is unique, and then non-unique elements, we got false. All right, so we saw kind of 3 different, I've seen people try to do this, like give me every other element, right? So I wanted to go through different ways of doing it, right? One is to use the range. Right? And remember, this worked well, but we had to then select the current element as the element's index. And then we also had a gotcha where when we got to the end of the list, we got this index out of range because we're trying to find something after the end. So we have to do range length of the elements -1. All right. So I'll save this as a gist and share this with you all. It's probably worth going through these different ways of solving the problem. Enumerate, the range, the counter, right? And of course there's the pre-processing step, right, of sorting it. But, oopsies. Oh no, did I lose it? All right, 2 ways to solve the problem. Just kidding. I'll write it out. Questions about this? No? All right, and then once we went through these things, you should be able to use a similar technique to do reverse a list. I won't spoil this one, so I'll let you solve that. So let me, I'll replace I'll do this, the enumerate, no, which one do I have to do? Index, oh, the counter. All right, I have to write out the counter one again, but I'll do that offline, and then I'll share this with you all. Okay, I'll put you guys back in breakout rooms, let you keep going, unless there's any other questions.